The accelerometer is a small motion sensor inside the phone that detects movement and orientation. Whenever you tilt, rotate, shake or lift your device, the accelerometer picks up those changes. It does this using a tiny internal mass suspended on microscopic springs. When the phone moves, that mass shifts slightly. The sensor reads that shift as a change in electrical signals, and converts it into movement data your phone can understand. This is how your phone knows when to switch between portrait and landscape, wake the screen when you lift it, count your steps, and track motion in games or apps. The accelerometer is one of the core sensors that makes your phone feel responsive to how you move it. Infrared blaster sensor. This sensor helps your phone to send IR signals just like a TV remote. Inside the module is an infrared LED that emits a beam of invisible light when the phone triggers it. It doesn't receive anything, it only transmits. When you press a button in a remote app, the phone copies the same pulse pattern that a real remote would send. Any device that uses an IR remote, like a TV or AC, recognizes the signal and responds instantly. Since it doesn't need Wi-Fi or Bluetooth, the IR blaster works with both modern and older appliances, and turns your phone into a universal remote. GPS. This sensor listens signals from navigation satellites. GNSS is the overall category, and GPS is just one of the satellite systems your phone uses. Modern phones listen to several systems at once, including GPS, GLONASS, Galileo, Beidou and others. Each satellite sends out a precise, time-stamped signal. When your phone picks up signals from at least 4 satellites, it compares the tiny timing differences between them. Each timing difference tells the phone how far it is from that satellite. With 4 or more distance measurements, the phone can calculate your latitude, longitude, and altitude accurately. Using multiple GNSS systems gives faster, more reliable location tracking for navigation, fitness, and emergency services. Ambient light sensor. This sensor measures the light around your phone. Its job is simple, it checks how bright or dark the environment is. Inside the sensor is a tiny photodiode that reacts to incoming light. When light hits it, the electrical output changes based on how strong the light is. This is why your screen brightness adjusts automatically, and saves battery by avoiding unnecessary brightness. Gyroscope. This sensor measures rotation. While the accelerometer feels basic movement and tilt, the gyroscope detects how fast and in which direction the phone is turning. Inside the sensor, there are tiny vibrating structures. When the phone rotates, the vibration pattern shifts. The sensor reads those shifts and converts them into precise rotational data. This is why your phone can track smooth 360-degree motion, stabilize video, improve AR accuracy, and make gaming controls feel more natural. The gyroscope works together with the accelerometer to give your phone a complete sense of how it's being moved in real time. Magnetometer. This sensor helps your phone to understand direction, just like a digital compass. It detects the Earth's magnetic field and uses that to figure out which way the phone is facing. Inside the sensor are tiny magnetic sensitive elements that change their electrical signal when the magnetic field around the phone shifts. The phone reads those changes and converts them into north, south, east or west. This is why maps can show your facing direction. AR apps know where you're pointing, and the phone can align navigation accurately. And this gives your device a sense of orientation in the real world. Proximity sensor. This sensor detects how close something is to the front of your phone. You mostly notice it during calls. When you lift the phone to your ear, the sensor realizes something is very close and turns the screen off. When you move it away, the screen turns back on. It works using a small infrared emitter and receiver placed near the top of the display. The emitter sends out a short invisible IR beam, and if something is close, that beam reflects back into the receiver. The phone measures that reflection and knows an object is near. This simple sensor prevents accidental touches during calls, saves battery, and helps features like pocket detection and face-down gestures work properly. Barometer. The barometer is a small pressure sensor inside the phone that measures the air pressure around it. Since air pressure changes with height, the phone can use the sensor to estimate your altitude. The barometer detects the tiny change through a flexible membrane inside the sensor. As pressure pushes against the membrane, its electrical signal changes. The phone reads that signal and translates it into elevation data. This helps with more accurate GPS tracking, faster location fixes, and better weather apps. The barometer gives your phone a sense of vertical movement that GPS alone can't handle. Fingerprint sensor. This sensor scans the unique patterns on your finger and uses them to unlock your phone securely. Depending on the type of sensor your phone has, it reads your fingerprint in a slightly different way. Capacitive sensors use tiny electrical circuits that detect ridges and gaps when your finger touches the surface. Optical sensors shine light through the screen and capture a detailed image of your fingerprint pattern. And ultrasonic sensors send small sound waves through your skin and measure how those waves bounce back, which lets them capture depth and texture. Hall effect sensor. This sensor detects the presence of a magnetic field and uses it to understand when something with a magnet is near your phone. Inside the sensor is a tiny semiconductor strip that produces a small voltage when a magnetic field passes across it. When you bring a magnetic flip cover, a stylus, or any magnetized accessory close to the phone, the magnetic field changes. This is how your device knows when a flip cover is open or closed, how some cases trigger smart window modes, and how foldable phones detect their hinge position. Ultra-wideband. UWB is a short-range high-frequency radio technology used for precise distance and position tracking. It works by sending very fast radio pulses between two UWB chips, or between a device and multiple UWB anchors, and measuring how long the signal takes to travel. This travel time is called time of flight, because the signal moves at the speed of light. Even tiny timing differences translate into extremely accurate distance measurements. This allows UWB to enable digital car keys, device-to-device ranging, and indoor navigation with high precision, which is why it's used in premium phones and smart home systems. NFC. This is a short-range wireless system built into the phone. It uses a small chip and a coil antenna to exchange data when two devices are very close. It doesn't sense anything like motion or light, it simply communicates over a few centimeters using magnetic induction. This is how NFC tags, tap to pay, and unlocking doors works. Some older smartphones included extra environmental and health sensors that modern phones no longer use. Samsung Galaxy S4 had a temperature and humidity sensor, which was used to show indoor climate readings. The Galaxy S5, S6, S7, S8, and Note 4 added a heart rate sensor, which measured your pulse directly from the phone. The Galaxy Note 4 also included a UV sensor, which checked UV intensity and warned about strong sunlight. All of these sensors are now obsolete, and no current Android or iPhone includes them. So, that's all for today's video. If you learned something new, make sure to like the video, share it with your friends, and subscribe to the channel.